All right, so number 2 gives us, our first example that we're going to look at is number 2. It gives us a right triangle. I would like for you to draw it. It tells us that the legs, not the hypotenuse, but the legs are 6 and 8. It labels the triangle ABC. C is where the right angle is located. And theta, they've drawn theta in at angle A. So that's our diagram for number 2. The directions say, use the Pythagorean theorem to find the length of the missing side of each right triangle. Then find the value of the 6 trig functions of theta. So first we've got to find this missing side. Usually they label it little c because it's opposite of big angle C. And we're going to use the Pythagorean theorem to find our missing side. So Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Or in this case, a squared plus b squared equals c squared. And we fill into the Pythagorean theorem, and what would that look like when we fill in using this right triangle? Okay. So it doesn't really matter what A or B is, but you have to make sure you get C right. C is always the hypotenuse, which is the side opposite of the right angle. So you could do 8 squared plus 6 squared or 6 squared plus 8 squared. That won't matter. I would take my calculator and actually do 6 squared plus 8 squared. Unless you can do that in your head, that's 100. So 100 equals c squared. We'll use the square root property, which your wonderful Algebra 2 teacher taught you that. Take the square root of both sides. And c technically is equal to positive or negative 10. But in this situation, we're talking about a side of a triangle. So sides of triangles can never be negative. So c is equal to always the positive number there. So you're going to put that into your triangle, and then you're going to find your 6 trig functions. So we're going to start with sine. Sine of theta is the opposite over the hypotenuse. So you got to find theta. What's the opposite side to theta? 6 over the hypotenuse, which is 10. So these are the type of questions that pop up on the ACT. They just want the sine ratio of theta. So it's 6 over 10. If it needs to be reduced, you have to reduce it. So 6 over 10 reduces to be 3/5. So sine of theta would be 3/5. Cosine of theta would be adjacent over hypotenuse. So that's going to be 8 over 10, which reduces to be 4/5. Then they want tangent of theta. Tangent of theta is opposite over adjacent, so that would be 6 over 8, which reduces by 2 to be 3/4. So again, I find my 3 major trig functions, and then I find the other 3 by just doing the reciprocal. So then cosecant of theta would be 5/3. Secant of theta would be 5/4. And cotangent of theta would be 4/3. Okay, first part of your homework, that's what they're going to be asking you to do. Questions about number 2? All right. If you end up with a square root in the bottom, you are going to have to rationalize. I'm not going to do any more from that section. The next problem I'm going to do is, I lied. The next problem I'm going to do is number 8. It comes from that section. They're going to give you another right triangle. It's going to look something like this. You do not have to draw the diagrams in your homework. It's just good for your notes to have a picture of what you're doing. Okay, again, the directions are going to say use the Pythagorean theorem to find the missing side. So this time we're finding side B, little side B, because it's opposite of big angle B. So we're going to use Pythagorean theorem. A squared plus B squared is equal to C squared. Remember, A and B are the legs of the right triangle, and C has to be the hypotenuse. All right, so here you're going to have 24 squared plus B squared is equal to 25 squared. Or you could have a squared plus 24 squared. It really doesn't matter, but the 25 squared's got to be on the right-hand side. All right? So we are all past Honors Algebra 2. So on your calculator, I would do 25 squared minus 24 squared. Y'all get that? Let's do quick solving here. You're going to have to move the 24 squared over to the right-hand side, so just do 25 squared minus 24 squared in your calculator. That gives you what number? I got 49. Okay, 25 squared minus 24 squared is 49. Take the square to both sides, either on your head, in your head, or on your paper, and B has to be positive 7. Everybody get how I got 7? And then we're going to fly through our little trig functions. So find theta. Sine of theta is opposite over hypotenuse. So what fraction represents that? Opposite over hypotenuse. 24 over 25. Cosine is adjacent over hypotenuse. Adjacent to theta. 7 over 25. Tangent is opposite over adjacent to theta. That would be 24 over 7. And then we find our reciprocal functions. Cosecant comes out to be 25 over 4, secant 25 over 7, cotangent 7 over 24. All right, if you're having trouble with opposite and adjacent, here's something that you can do. You can highlight the hypotenuse. If you highlight the hypotenuse, that makes you realize that 25 could never be opposite or adjacent. 25 is the hypotenuse. It is never the opposite leg or the adjacent leg. And then when you think opposite and adjacent, you're thinking that in reference to your angle. So theta, the adjacent leg to theta, is the one right next to it, which is the length of 7. The opposite leg is the one you got to walk across the triangle to get to. Opposite would be 24. So sometimes if you highlight the hypotenuse, it takes that side out of being opposite or adjacent. Any questions about number 8? All right, next set of directions. They're going to give you 2 triangles. One, actually they're both special. One is a 45-45. You learned about special right triangles in honors geometry. You may have totally forgot about them. They are sometimes on the ACT. A 45-45 has 2 legs that are equal. This one we're just going to do the basic 45-45 where the 2 legs are 1. Anybody remember the relationship between the legs and the hypotenuse on a 45-45? There's something that's always true that you can do to the leg to get to the hypotenuse. Okay, I'll tell you. Multiply by the square root of 2. So in a 45-45 right triangle, it's always true that the leg times the square root of 2 is the hypotenuse. You really don't have to have that memorized, although you studied it before. All right, so in a 30-60 right triangle, that's the other special right triangle. Y'all remember having a short leg and a long leg? You may not remember exactly what that is. If the short leg is 1, it's the side opposite of the 30. The side opposite of the 30 has to be shorter than the side opposite of the 60. So the side opposite of the 30 is 1. The side opposite of the 60 is 1 times the square root of 3, which will be, in this case, square root of 3. And then the hypotenuse is the short leg times 2. So 1 times 2 is 2. The good thing is they're giving you those triangles. You don't have to know those rules, even though somebody's taught them to you before. Alright, so that's in your directions. Given the triangles, evaluate each expression. If necessary, express the value without a square root in the denominator by rationalizing the denominator. So using those triangles, number 10 is asking you to find the tangent of 30 degrees. Using the triangles, not your calculator yet. Okay? Which triangle has 30 degrees in it, the first one or the second one? The second one. So you're only looking at the second triangle, so don't let the first one confuse you. Tangent is what over what? Opposite over adjacent. So from the 30 degrees, the opposite leg would be 1, and the adjacent leg would be square root of 3, because we're going to highlight our hypotenuse here. All right. Can my answer be 1 over the square root of 3? Nope, can't have a square root in the bottom, so we're going to rationalize, and my final answer there is square root of 3 over 3. If you use your calculator for the tangent of 30, you will get a decimal form. You won't get square root of 3 over 3. They're not wanting decimals here. They're wanting you to do these by hand. All right, number 12. Cosecant 45 degrees. Okay, which triangle has 45 degrees in it, the first one or the second one? The first one. So you're going to go to the first triangle. You're going to think sine, okay? Cosecant is the reciprocal of sine, so you're going to think sine. Sine is opposite over hypotenuse, but this is the reciprocal of that. So then it's going to be hypotenuse over opposite. So that's going to be what? Square root of 2 over 1, which just simplifies out to be the square root of 2. Did that make any sense? Okay. So what I do in my mind is I think cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So cosecant is going to be the reciprocal of that, which is hypotenuse over opposite. All right, same section. Let's look at number 18. I'm going to erase so I can keep my little triangles here. Alright, so number 18, this is where it starts to get harder. So 18 is still in the same set of directions. It's asking you to find the cosine of pi over 3 and multiply that times the secant of pi over 3 and subtract the cotangent of pi over 3. Alright, believe it or not, that's in the same set of directions where it says use one of these two triangles. So first of all, this problem is harder because you're using radian measures, but that's okay because you're smart. You know what pi over 3 is in degrees. It's 60. Okay, good. Alright, so all of these are really 60 degrees. Okay? Not only are you really, really intelligent, but you also know that cosine and secant are reciprocals. So I don't even have to find the cosine of pi over 3, guys, and I don't even have to find the secant of pi over 3 because I'm multiplying two things together that are reciprocals. So anytime I multiply two things together that are reciprocals, I always get the number 1. Okay? Now, if you want to find the cosine of pi over 3, and you want to find the secant at pi over 3, and you want to take the time to multiply those together, you can do that the long way, but you will get 1. Anytime you're multiplying two reciprocals together and you have the same angle there, you have to have the same angle for that to work, your product will always be a 1. Now, we do have to find the cotangent of pi over 3. So y'all told me pi over 3 was 60. Cotangent is the reciprocal of tangent. Tangent is what? Opposite over adjacent. So cotangent is going to be adjacent over opposite. So I erased my little adjacent. So what is adjacent over opposite for 60? 1 over the square root of 3. Anybody want me to repeat how I got 1 over the square root of 3? Okay, so my answer right now is 1 minus 1 over the square root of 3. I can't have the square root of 3 in the bottom, so I'm going to rationalize that second value. And I'm running out of room. And that's going to give me 1 minus what? 1 minus the square root of 3 over 3. Are those like terms? 1 minus the square root of 3 over 3? Not really, okay? This is an okay answer, but I'll show you what the book is going to do. They're going to think about that 1 as being 3 over 3. They're going to think about 1 being 3 over 3. And then they're going to subtract the square root of 3 over 3. That's called finding a common denominator. And they're probably going to write the answer like this. So if you're doing WebAssign is attached to the Blitzer textbook. So they might want the answer typed in like the second answer. And you're just going to have to start figuring that kind of stuff out. All right, any questions about 18? All right, we are going to move on, and we're going to talk about cofunctions. Everybody got 18? All right. I need you to write cofunctions. I'm gonna throw out a lot of information in the first couple weeks just because this is just a whole new course to you. I promise I'll be fair in the end. Y'all just hang on. If you're taking notes and you're thinking and you're doing your homework, you're gonna be okay. All right, write this down and I'll explain to you what cofunctions are. Y'all want to go back to Algebra 1A? That's what they're doing over there. Right. So let me kind of, in just a real fairly simple explanation, show you what cofunctions are and why we use them sometimes. So, if I have the sine of 40 degrees, that is going to be equal to the cosine of 50 degrees. Okay? They're going to ask you for a cofunction value, and they're going to say, okay, what's a cofunction to the sine of 40 degrees? So you're going to have to know that sine and cosine are cofunctions. All right? And I got the 50 by doing 90 minus 40. So take your calculator real quick, make sure that it is in degrees. Find the sine of 40. And then find the cosine of 50. And please tell me that you're getting the same value. Make sure you're in degrees. It's the cosine of 40, not exactly the same value as is the sine of 40, not exactly the same value as the cosine of 50. Alright? You can do the same thing with tangent and cotangent. You can do the same thing with secant and cosecant. It all builds on the fact that sine is opposite over hypotenuse, and if you swap angles and you do cosine, then you do adjacent over hypotenuse, you're looking at the other angle in the right triangle, which would be complementary to 40, and 50 is complementary to 40 because 50 is 90 minus 40. It just all goes back to that right triangle trig. So example 22 is asking you to find the cofunction of sine of 19 degrees. So that's actually the problem. Find the cofunction of sine of 19 degrees. So you have to know that sine and cosine are cofunctions. So your answer is going to be cosine. And then you're going to do what to get the angle on your cosine? (90 minus 19), and that gives you 71 degrees. And if you totally blank out on Monday's test, could you not take your calculator and make sure sine of 19 degrees is also equal to cosine of 71? We're just asking you to practice writing cofunctions there. That's all that is. All right? How can they make this harder? They can make this harder by giving you a radian measure. So 28 is asking you to, they're giving you cosine of 3 pi over 8. And they're asking you for what's another trig function that is equal to cosine of 3 pi over 8. So they're talking about cofunctions because cofunctions are equal. So if they give you cosine, then you're going to use sine. And then you're going to do 90 minus 3 pi over 8. But we need to change 90 into radians. What's the radian measure for 90? Pi over 2. So I'm running out of room, but you'll do pi over 2, which is 90, minus 3 pi over 8. Sorry, that looks weird, doesn't it? So you'll do pi over 2 minus 3 pi over 8. You'll find a common denominator. That's going to be 8. So pi over 2 is really how many 8s? 4 over 8. 4 over 8. Pi is the same as, y'all get that? So 4 pi over 8 minus 3 pi over 8 would just be pi over 8. So sine of pi over 8 would be equal to cosine of 3 pi over 8. Those are called cofunctions. If they give you a tangent, then you're going to use a cotangent. You're just going to do 90 minus the angle. If they give you a cotangent, you're going to use a tangent. If they give you a secant, you're going to use a cosecant. You got to be careful here because we're not doing reciprocal functions here. So sine and cosine go together, tan and cotan go together, secant and cosecant go together. All right. Number 32. 32 is changing directions. They're asking you to solve the right triangle, so there'll be a diagram. The directions say find the measure of the side of the right triangle whose length is designated by a lowercase letter. Round your answers to the nearest whole number. All right, this is what you did in honors geometry. This is what we reviewed in Algebra 2 for the ACT. So we're trying to solve for side A. So we look at the angle that they give us, not the right angle, but the other angle. A is the opposite side. 13 is the hypotenuse. So what have we got to use? Sine, cosine, or tangent to solve this one? Opposite and hypotenuse. Sine. So we're going to write sine. We're going to abbreviate that. Of 34 degrees is equal to the opposite side, which is A, over the hypotenuse, which is 13. So we're going to set up an equation involving sine. I can't use cosine because I don't know the adjacent leg, and I can't even use the Pythagorean theorem to find that because there's not enough information. This is where you take sine of 34 and put it over 1, and you have a nice little proportion, and you'll just cross multiply here. So you'll do 1 times A is A. You'll make sure that your calculator is in degrees. And you'll do sine of 34 degrees, close parentheses here, times 13. There's no reason to ever write down the decimal for the sine of 34. Just do it all in your calculator and round 1 time at the end to the nearest whole number. That would be 7. Are we measuring by a certain unit? Meters. Okay? 7 meters. All right, I am out of time, so I'm going to tell you that y'all make sure that you work through number 33. Do 1 through 33. We'll come back and finish the notes tomorrow. Okay? So your homework goes past number 33. But we'll go over the rest of the notes in class tomorrow. So do you just make sure you do 133 and we'll finish that up tomorrow.